Okay, let's do chapter 14. That is about simple linear regression. Simple linear regression. Simple linear regression. Simple linear regression, we have two variables, basically. This is the independent variable that is going to affect my dependent variable. The independent variable is usually the x and dependent is y, such that there is a linear relationship among these two variables. Now, if what is this linear relationship? There is the formula for the line, okay? There is a linear relationship. This is x, this is y, this is my independent, this is my dependent variable. And remember, the formula of any line is what? Y is equal to b0 plus b1x. And what is this b0 and b1? Okay, b0 is the point of interception of the yx. This point over here is b0. And b1 then is the slope of this particular line. The slope can be positive, okay, can be negative. This is a negative slope, or the slope can be 0, okay? This is 0. There are no relationship between the variables. It really doesn't matter how I change my x, my y will not be changed. There is 0 relationship. That is why this slope is equal to 0. Okay, this is a positive relationship. For example, the more hours you study, the more grade you have in your test. This is a negative relationship. For example, in a car, the more the cylinders it has, the least miles per gallon. This is a negative relationship, okay? Now, in linear regression, we have a model. The model that says that y is equal to beta 0 plus beta 1 x plus epsilon. And epsilon should be a random variable, normally distributed, and the expected value of this random variable should be equal to 0. Okay, but this is the model. From the model, we have the regression equation. And the regression equation says that the expected value of y has to be equal to b0 plus beta 1 x. Okay? And this is the overall equation for the two variables relationships. Now, we have to estimate these parameters over here based on points. We have points over here. Data points given by what? Data. Something that you already have. Now, from these data points, we are going to try to find out this regression equation. This is the estimate of this regression equation, and this equation is y is equal to b0 plus b1 x, and this is the estimation of the regression equation based on these data points. And we are going to estimate these parameters using what is called the least square method. The least square method is finding the equation that minimizes the distance between each of the points and the estimated regression equation. Okay, and that is called a square. the least square method because this is a positive distance, this is a negative distance, so we need to square it in order to eliminate these negative numbers. And that's basically what is regression equation estimation. The formulas are in your book, so I'm not going to go into those formulas. And indeed, the regression equation is given by you using Excel, so you don't have to get into the formula, so don't do that. We have two concepts here. The correlation coefficient. Okay. Correlation coefficient. R. The correlation coefficient measures the strength and direction of the relationship between the two variables. Okay? And R can go from -1 until +1. So those are the range for the correlation coefficient. If we have a negative relationship, a negative correlation coefficient, we have a negative slope. If we have 0, we have no slope, and we have a positive relationship. So really, this R has the same symbol of my slope, or B1, in my regression equation. Okay. Another concept is the coefficient of determination. And that's R squared. And R squared, this goes from -1 to +1, right? This one from 0 to 1. And this coefficient of determination measures the percentage of the variance of the dependent variable that is explained by the variance of the independent variable. In other words, remember, we have this independent, dependent variable, and the coefficient of determination measures the percentage of the variance that is explained by this variable, this independent variable. Remember, in social sciences, one particular variable depends on many factors, not only one, but this one might be the most important factor. So you will never find a 1.0 in the coefficient of determination. You cannot find that, especially in social sciences, because there are many factors that may be involved in this dependent variable. Anyways, like what? For example, sales. Sales is my dependent variable, and my independent variable might be advertisement. Advertisement might influence sales, but not everything depends on advertising. There are many other factors involved. What else? Basically, right? And the coefficient of determination is R squared, and it goes from 0 to 1. Usually what we would like to find is above 0.5, 0.6. I mean, those are extraordinary values, because there are a lot of percentage of the explanation of this dependent variable that depends on this independent variable. Okay, assumptions. Okay, assumptions. This is important. What are the assumptions on linear regression? First of all, we are assuming that there is a linear relationship between the variables x and y, or the independent and dependent variables. We have what is called the homoscedasticity. That means that all the variances in all these x points are exactly the same through each of the x values. And of course, the expected value of my epsilon in the model should be equal to 0. Okay, what else? And these assumptions are very important because the basis for the regression equation are based on linearity among the two variables. Now, regression equation is used basically for prediction purposes. Okay, so we have a few points over here, and we want to check or to find out or predict what could be the value of my y if my x is equal to this point. So we just, okay, generate this line and see what is my y. This is the prediction purposes. However, be very aware when you use linear regression for prediction. Do not go beyond the range of my data points, because it may be that over these points there is no linearity. For example, and I already mentioned this, advertising influence sales, okay? Positive relationship between advertising and sales. However, sometimes when there is too much advertising, it may cause a negative effect. So overall, it may be that this might be the case. It has a point where more advertising really makes annoying and might influence sales negatively. So be very careful and use prediction purposes beyond your data range. Now, be very careful also in saying that this relationship or this independent variable cause the dependent variable. Hopefully, yes, but not always. I mean, this causation doesn't mean that if you have this relationship, a strong correlation, it doesn't mean causation. Causation, to be cause, one thing cause the other, it has to have what? Time precedence. Time precedence means that if X happens, Y happens, not the other way. Has to be first the X and then the Y, or first the independent and then the dependent variable. That's one. The second requisite for causation is a high correlation. And the third one is very important. We have to have theoretical explanation. Okay? What is this? I mean, why is that? Why is this so important? Okay, you may tell that every time you wash your car, it rains. And so we have this time precedent, we have this correlation, this strong correlation. I mean, it may be that every time you wash your car, it rains. But there is no theoretical explanation, okay? There is no reason why washing your car makes it rain. So, very careful. Causation has to have these three elements. Now, how do we test the linear regression or the regression? We test, what do we have to test? The null hypothesis and the alternative hypothesis. And the null hypothesis is that the B1 is equal to 0 against the B1 is not equal to 0. Remember, B1 is the slope of the regression equation. So when we have 0, the slope 0, we don't have any relationship among the variables, between the variables. And when we have a slope that is different to zero, strongly different to zero, then we do have a regression test of significance. And we might use the t-test with n-2 degrees of freedom, where n is the number of points. Not is the number of xy's, is the number of points in your data set. Okay? And the test is equal to B1, that is the slope, divided by the standard deviation of my B1, and that is given by Excel, so don't worry about that. And the other one, the other method to use is the ANOVA table, and using F with how many degrees of freedom? 1 in the numerator and n-2 in the denominator. And the test for this is the mean square of the regression divided by the mean square of the error. Okay? And you test in this, and you then, in this one, you have a two-tailed test. Okay? If you reject the null hypothesis, you conclude that you have a strong regression equation in your hands. The same thing happening here. And the ANOVA table, remember, gives you the p-value, gives you the f, gives you the critical value. Okay? And I'm going to mention only these for mention it, because Excels do not give you confidence interval or prediction interval. But when you have your regression equation, okay, you have a confidence interval for the regression equation. Okay, remember, you are basing your regression equation on data. So you have to build your confidence interval for that particular regression equation. And you have what is called the prediction interval. And this interval is used for prediction purposes. If you want to predict on this one, then this is the interval for the prediction in this particular point, basically. There are many software. Minitab gives you the confidence interval for the regression equation. It gives you the prediction interval for prediction purposes. SPSS also gives you this, but Excel does not. So I just want to mention this. And basically, that's it. I mean, the regression equation is linear regression equation is pretty straightforward, and I'm going to show you this in the computer.